Hi everybody, this is our computer programming project. For our main project, we are going to do the calculator. First off, I'm Amesh Gomes. My metric number is 186572.
I'm Adnan, Al-talib. My metric number is 190541.
I am Yunus. My metric number is 186541.
I'm Abdulaziz Salem. My metric number is 190537.
I'm Ammar Abdulraqeb. My metric number is 186563, and I'm going to talk about our project today. In our project, we have decided to make a calculator and simulate it. This calculator will do the basic operation in between two single numbers from 0 to 9. And the calculator have an LCD and the keypad. The keypad takes your input, and the LCD will show your input and your output of the calculation. Like if you press 1 plus 1, the LCD will show 1 plus 1 and the answer of the calculation, which is 2. Next. In our objective, we have set the objective for ourselves, which is developing a program using the C language to solve scientific problems, and to develop an interactive program that displays the numerical results and identify the programming errors in C and build a C language functions. And now we are going to talk about the C language compilers. When you are creating any program, you will need a compiler that will run it, so the computer will understand the language, because the languages are different from the language that you put it in your programming and how the computer receives it. Using a C compiler will convert your program into a language that the computer understandable by the computer. This is called the machine language. And so before proceeding, make sure that you have a C compiler like the def C++ that we are using in our program. PIC microcontrollers. PIC microcontrollers are very useful tools for many electronic projects. They are very cheap and easy to find. Their speed gets up to 64 MBs. And PICs are easy to program, and to program it you need IDE like MPLAB, and Yunus will talk more about it and explain how to program using MPLAB.
The MPLAB is an IDE for the PIC microcontroller. Now we will look how to create a design file using MPLAB. The 5 steps are high-level design, software coding, generate executable, test, and burn into device. Okay. For the first step, for the high-level design, for our project, we are using the PIC 16F877. And then, so as you can see, we designed the associated hardware circuitry. Then the second step, it's the software coding. So we either assembly the language, which is directly translatable into a machine code, or we use a compiler that allows a more natural language for creating programs. As we have learned in C programming, we need a C compiler that need to be installed with the MPLAB so that we can proceed. So we compile and assemble the software using a language tool to convert the code into a machine code for the PIC micro device. So we then check the errors and correct it, this is the 4th step. And then for the 5th step, we burn the code into a microcontroller and verify that it executes correctly into the finished application. Then we create the .text file and we put it in the microcontroller. Good.
Hello guys, we're going to talk about the Proteus. First of all, Proteus combines advanced schematic capture, mixed mode, SPICE simulation, PSB layout, and auto-routing to make a complete electronic design system. The Proteus products range also includes our revolutionary VSM technology, which allows you to simulate microcontrol-based design complete with all surrounding electronic. Since we're not using the hardware to make the calculator, we're going to use a software called Proteus, so we are going to simulate the calculator, and now we're going to show you how to use it. So here's the simulation, and we're going to talk about how can we control and what's connected to the LCD and what's connected to the keypad. First of all, from row A to C4 is all connected to the keypad, and from E to D7 it's all connected to the LCD. All the inputs and the outputs are connected to each other. So now we're gonna just run the simulator by pressing the play button. Like for an example, now we're just going to put some random numbers, let's say like 3 multiplied by 4 equals, that's it. And like for another example first, so just so you can clear the LCD, you can just press the C button, and for another example we can just, for another random number 6 divided by 3. That's how it works, guys.
So now we're going to talk about the code behind the simulation that you just saw, shown by Adnan. To look at the code, we are going to use MPLAB combined with a C compiler for us to write the code. Starting off, we have 3 .c files, one for the LCD, one for the keypad, and our main .c file. Going into the main C file, first we have a header which is includes.h. Actually, we have 3 headers: one for the keypad, one for the LCD, and one includes, which is in all of the .c files. Okay, first off, we need to configure the PIC 16 F877 we are using, which is what we have done in line 3. And now we go on to our main function. First off, we need to tell what are our characters and our integers are. First is for to show that the key is pressed. Number 1 is for the first number. Number 2 is for the second number. And then we need to initialize the keypad and the LCD. Going on, we need to create a loop, an infinite loop, which is done by putting a while 1. In our infinite loop, we need to get the first number and the second number. To get the first number, we are going to first initialize and make sure there's no error. So in an if loop, if there is no error, the code gets run. At any time, if the user presses the clear button, we need to make sure that in the LCD it gets clear, everything gets clear. So we need to clear the thing by using this code over here. When you're getting the functions, after you get the first number, you need to tell an operation you need to do, either plus, minus, multiply, or divide. Which is what we are doing here, which is the get function part. Which is get key is actually in our keypad.c file, which specifies which function we are getting, which operation. Moving on to getting the second number, which is just like our first number, we need to make sure that there is no error involved. As you can see here, we are going to get the key using the keypad.c file, and we are going to write it in the main function. Okay, as you can see, this is the switch operation. When the user types in either plus, minus, divide, or multiply, we need to make sure that there's a case for each operation they use. So over here we have created 4 cases in a switch statement to make sure that when they type in multiply, the 2 numbers actually multiplies. Now going down, that is it from our main function, but we have created more functions for the calculator to work. So that's the end of our main function. So moving on to the next function, which is the get number, which is getting the number from the user. Actually, it is actually from the keypad as well. We need to make sure that every number has a different case. Because it's from 0 to 9, we need to make sure there's one case for each number. So moving on, And at each step, we need to make sure that if the user presses clear at any time, we need to create a case for when the user presses clear LCD, which is the C. Okay, moving on. This is our get function, which is to get the operation from the user. In this thing, we also have to create the clear LCD and an operation and function to get the operation, and we need to make sure that the user enters a correct operation. If at any time he puts the wrong code, it has to give out error. So moving on, from this function, we go on to the LCD, which is to display the error when if the user presses any error during the simulation. In simulation, we need to make sure that after the errors are shown, after the error message is shown, which is shown in here, at any time, we need to make sure that after the error is shown, when the user presses clear LCD, the LCD gets cleared. Moving on, afterwards. So the next function is the displaying the number function. As you can see, we need to make sure that if the user presses negative or 10, it can't be used in the program. So we need to make sure that it's a positive as well. And we need to make sure that 0 doesn't get applied in this thing, because for this calculator, it is worked in whole numbers. You don't have decimal places at all. So this is for displaying the number on the LCD. As you can see, so if it is pressed to 0, we need to make sure that it's not displayed in the LCD. So this over here, if it is not 0, it doesn't get, if it is not 0, it gets displayed. If not, it doesn't. That is it for our main.c file, but we also have our keypad and our LCD. Okay, so in addition to the main.c file, we need the keypad.c and the lcd.c. The reason for this is because in the simulation, we need to actually connect the LCD and the keypad to our PIC when we make the .hex file. So what the LCD.c and the keypad.c is basically, what it does is it connects the PIC with the LCD and the keypad. As you can see, we need to make sure that each pin is connected to the PIC with the LCD as well as the keypad. This is the main functions of both of these two, LCD and keypad.c. In addition to these three, like I said before, we have used three headers. One is includes.h, the other two are the keypad.h and the lcd.h. The reason for keypad and LCD headers were that all these functions were done because of those two headers. Without those two headers, none of this would be possible. And the includes is used in all of our .c files. With that is also these functions that we have used won't work. We have run this whole C in MPLab, like I said before, with the C compiler. So we have created the whole code in MPLab using the C compiler, and that is it from the code part of our project. We build this using the build key to get the .hex file, which is used in our microcontroller in the simulation.
So this is all for our project. In conclusion, in this mini project we have learned how to create a code from a calculator and simulate. It using Proteus software. The calculator can use the basic operation between two single digit numbers from 1 to 9. We learned how to display the numbers on LCD and get the numbers from a keypad. We also learned about the PIC, microcontroller, on how it can be used to create projects as well as MPLab, which is an IDE for the PIC, and combining it with a C compiler to write the code and identify the errors to make the program run successfully. So this is all for our project. Thank you for watching and goodbye.